3, 2, 1. Hi everyone. In this video we're going to be going over the week 6 activity sheet, specifically what we couldn't get through in class, which was trying to show that we could get to the formulas for the surface area and volume of some of our 3D shapes by just thinking about what we know about 2D shapes. So we're going to be starting with the rectangular prism, which I have beautifully constructed one, perfect in every way. Don't look too closely. A much better one you can see on the document here. And so what we're going to try to do today is find the surface area formula just by looking at the area formula for a two-dimensional rectangle. So I've color-coded the sides I want to talk about. So you see the red side here, and I have a little illustration of that rectangle. There is a purple side, and that's the purple side, and then there is a green side. This is the green side. So the goal here is to use the formulas that we know about each of these rectangles in order to construct the surface area of this prism. So first of all, what is surface area? Surface area for a 3D shape is the way we describe the outside. So if you want to think in terms of something like this, this construction, this prism, the surface area would measure how much paper I would need to build this. So this is hollow right now, nothing inside. So the only paper I need is to construct the outer portion. So there is a formula for this that we will get to, but if we didn't know it, how could we figure out what that would be? The way to do that would be to understand that this 3D picture is really just a couple of 2D rectangles all put together. You could think of it like being glued together. And so what we have to do is we have to break this 3D shape into its 2D components and then just find the area of each of those. So for example, we see the red side here. This is a rectangle. We want the inside of the rectangle here. Well, that's just the area. And if we go to our formula sheet, the area of a rectangle is base times height. Okay, so if I do the base times height of this red rectangle, that's going to be part of my surface area. But I get a little extra free here because this side is the same as this side, right? This side and this side are the same exact side. So they're different sides, but they're the same rectangle. So if I want the surface area, I do want this and I want this side, which means actually, if I want the surface area, I need two of these. So two copies of this. The same works for the other sides. So I've got the green side here. I want this area plus this area, which means I also need two rectangles. And lastly, so what have I done so far? I've gotten this, 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 this. So all of these sides. Now I just need, if I'm holding it this way, the top and the bottom. So let me flip it this way. So here's the top, the purple, but also the bottom is the same exact rectangle. So altogether, I need two of these. So now that we've got the shapes and how many we need, we then need to write this into a formula. So the surface area will be 2 of the red area plus 2 of the green area plus 2 of the purple area. Okay. So we have which sides we need to add and how many of them. 2 red, 2 green, 2 purple. But we need to actually know how to calculate the area of each of those. And we need a labeling for that. So we go back up and we see for our original prism, we've got a width, a length, and a height. Okay, so then all we have to do is match up each of those with the right side. So for the red side, that uses a height. So let's drag a height over here. That's one of these. And it's this front side, uses a length for its bottom. Okay. All right, what about the green side? That's right here. That is a width for its base. Oops, wrong one. That is a width for its base, and then a height. Okay, and then lastly, this top and bottom right here is a length and a width. So we can grab this one. That's a width. Let's put that back over here. And then we need a length because it's the base. Let's grab that and put it here. Okay, so we know this is the height, this is the length of the original 3D shape. This is the width of the original 3D shape, and this is the height. This is the length of the original 3D shape, and this is the width. So then we can rewrite this as the red area, just using our 2D formulas, is height times length. The green area is 2 times height times width. The purple area is 2 times length times width. And we have our surface area formula. 2 times the height and length, then you add to 2 times the height and width multiplied, then you add 2 times the length and width multiplied. That gives you the total surface area of your prism. So we have the surface area of our prism. What about the volume? So what is volume? Volume for a 3D shape is how much is inside. So I said that this shape was hollow, and it is, but if you wanted to fill it up with something like water or sand, if you did that, the volume would measure how much of that water or sand you were able to actually fit inside the shape. So finding this formula from just the 2D formulas is a little tricky, and it's going to take a little bit of a leap for you to believe possibly, but we're going to talk about it a little bit, and hopefully you can kind of believe the idea. And so here's the idea, and it still goes back to the two-dimensional shape, right? So what I want you to think about is taking this shape and just taking a slice of it. I don't know why you would slice a cake like this, but let's pretend you're going to slice a cake horizontally. And so if you slice that, you'll end up getting a little two-dimensional rectangle. And so then what I want you to think about is I could build this shape by just taking this rectangle, right, and stacking a bunch of them on top of each other, right? So it's almost like I could fill this shape up by just adding a bunch more of these rectangles all on top of each other until I hit the top. Okay, so then what I'm trying to convince you of is that the volume of this shape is really just made up of a bunch of these areas stacked up on top. So then what should that look like? Well, the volume then, the formula, should look like the red area, okay? And then I'm saying I'm going to stack them on top of each other. But what does that sound like I'm saying? It sounds like I'm saying add a bunch. Okay, add a bunch of what? What do you mean add a bunch? Well, you start here and then you add until you've hit the top. But how far did you go, right? So how far did you go is you went up until you hit this point. And we have a way to measure this point here. So based on our original picture, right, we had it sitting this way where we had said this was the height, right? This was the width, here was the width, and this was the length. Our original picture had those L, W, and H. So if I tip it back over, this here then would have been the width. So what we're saying is I somehow have to figure out how do I take this and stack it up on top, just one after another, stack, 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 until I've hit here. And I'm saying somehow go from the bottom up to the width. So let's think about this. Mr. B saying add, 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 add. What's our shorthand math way to say add a bunch of stuff? Well, our shorthand math way to say add a bunch is to say multiply. And I know somehow the width, because that's this here, the width has to be involved. So I can take a guess and say, how about I multiply by the width? Let's think about that for a second. If I made this taller, up here maybe, I stacked another one on top, would multiplying by a bigger number give me a bigger volume? It would. Okay, that works. It makes sense. What if I was to take this and make it smaller? Does multiplying by a smaller number make my overall volume smaller? Yep, it would. Okay, that fits. Now this is not a proof in any way that this formula will work. It does, but hopefully you get the idea that we're really just taking this 2D shape and in some sense just adding it to itself a bunch of times, and that should be determined by this W here, how big this is. So let's actually write this formula out. So we have the red area times W, the width. So we go back up. What was the red area? It was height times length. So let's copy this. Oops. Copy this. Volume. And the red area is height times length. So what do I get all together? The volume of my prism is the height times the length times the width. There you go. So all together, let's make these capitals so they match. All together, I have the surface area is 2 times each side area, height length, plus 2 times height width, plus 2 times length width. The volume is just all 3 of the different lengths multiplied. Height times length times width. So the next shape we are going to be discussing is the cylinder. So here's a cylinder. Again, wow, masterfully done. Look at this. A top, everything. Nope, the top is definitely attached. Don't worry about that. So we are interested in first the surface area of this thing. All right, so again, surface area is outside. How much paper was needed to make this cylinder? So there's a few things we're going to need for this. Let's check out what they are. Okay, we're going to need the area of the circle, pi r squared, the perimeter of a circle, 2 pi r, and a mystery formula that might not be apparent right now, but I'm going to make one move with the cylinder and hopefully you'll see why we need it. So let's start with the circle. Now, I want the surface area. So the first thing I do is I need the surface area of the top here, right? But the top, I don't need surface area, I need area because look, the top is just a circle, right? And so all I need is the area of this circle. I can take that off. I know how to find the area of a circle. I'll put that down. Okay, so now I just have this left. Well, it's not just one area of the circle because on the other side there's another circle. So for the surface area, I actually need 2 area of the circle. Okay, but we know what that is. We don't have to even write that out. We can just use the formula. That's pi r squared. So my first piece is done. This here is from the top and the bottom. Okay, so I've got all the material for the top and the bottom. Got that done. But what about this right here? What about this circular piece. Not quite sure how to make this 2D, but if we're really tricky, we can make this a 2D shape. And here is how we do it. Get my tools. Be very careful if you try this at home. I've practiced this many times to make sure it's safe. I am going to cut along this line. And as I'm cutting, I want you to just pay attention to the fact that this line here, I drew it in black, that's the height, h. So you can see that on the diagram. I'm cutting along the height here. Okay, so we cut along the height. We cut along the height. Okay, and you're going to see what we get. I will flatten it out for you. Make it something that you can see a little bit better. What shape do we end up with? We end up with a rectangle. So if you are flabbergasted by this, I would suggest taking a piece of paper that's a rectangle, seeing if you can create a cylinder out of it. All you have to do is fold and attach. So okay, what do we need to do here? We need to find out how to find the area of this rectangle. Well, it's not too bad. We can see here we have this height as one of the edges of this rectangle. So remember, the area of a rectangle is this length times this one. Okay, so that black edge here, so I'm going to put a plus symbol in my formula. This black edge here, we said that was the height, so I'm going to write that down, h. That's my height. Now this blue, what was this blue? Well, let's go backwards and recombine this and see if we can figure it out. We recombine this. We want to know what this blue distance is. But remember, what was up here? The circle was up here. And let's think about this. That distance all the way around is the same thing as saying, I'm going to go all the way around the circle. But I know what that is. Going all the way around the circle is the same thing as its perimeter, or when you're talking about circles, you'll often hear the word circumference. So this blue is the same as this blue all the way around. So this is going to then be the height times, and then the perimeter of the circle. And that's my formula. The surface area of a cylinder is 2 pi r squared. That's top and bottom. Then we add to that the all the way around piece, which is the height times the circumference or perimeter of the circle. Because, again, that's what I had here, right? This was the circumference. I know it's flat now, but it was the circumference of the circle when it was all curled up. And this piece here is the height. So again, just so you can see it, that comes from this. And it's not perfectly put back together, but that was our original cylinder. All I did was cut it, flatten it out, and it became a rectangle. All right, so we've got our surface area. Great. What about the volume? So the volume, again, we're thinking of, I want to fill up this cylinder. So water, sand, whatever you want to fill the cylinder with. And the question is, how do I measure that? That's the volume. So we're going to use the same idea as for the prism before. If I think about taking this and just kind of slicing it, I'll end up with a circle. Okay? So how do I fill this up? I can think of taking this circle and stacking a bunch of circles on top of each other and adding them all up, all these areas up, all the way until I hit the top. So again, my formula, what happens there? Well, I said take the area of the circle. So let's copy the area down here. That's one circle. And then remember, I'm adding, add up. So adding a bunch is the same as multiplying. And then, right, I want to add up, all the way up, and then I stop eventually. But where do I stop? I stop when I get to the height. So then I multiply by our height. So the volume then of the cylinder is the area of a circle, and then times the height, which means add up a bunch of these until you hit the height.